Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface, and in the previous lecture we discussed working with primitive array types, how to pass them to C++, how to return a Java array from C++, and we mentioned that this JNI environment is very important. It has a lot of nice functions or methods that facilitates the process of converting C++ arrays to Java arrays and vice versa. And the most important ones were the ones to copy the memory values of a Java array to a C++ array. So the method was set double array region, and the other method was get double array region, which copies the values of a C++ array into a Java array, and this is a direct copy. Okay, but there are a few things that we have to be careful about. One is, if I go back to the Eclipse and our code that we wrote in Java, which had a couple of native methods, and we did some implementation here. Note that here, unlike Java, which every array is an object, right? So arrays are objects, and object allocation always happens on the heap. So it's a dynamic memory allocation. Java never allocates anything on the stack, or you cannot do that. Java has a stack frame, but it's managed automatically. But in C++, we can allocate on stack or heap. So it's a stack allocation or dynamic memory allocation. So stack allocation is very fast and it's automatic managing. Heap is not. So heap is manual managing in C++. Now in Java we have garbage collector. So garbage collector runs in a background thread and does the job of freeing memory for us. But in C++, heap allocation is manual, so we have to manually allocate, and then we have to manually release that memory when we're done with the array or whatever object that we allocate on the heap. Okay, so stack allocation is fast. The problem with stack allocation and all of these allocations that we did for this C++ array, JCC array, or here this one, these are all allocation on the stack, and it's very fast. But then a stack has a very limited size, right? The size of a stack very limited. So automatic, limited size. Heap is manual, very large size. So let's say I want to work with an array that has 1 million elements in it, right? And if each element is a double number, I have 8 million bytes, because each double is 8 bytes. So 8 million bytes is 8 megabytes. And that's very hard for the stack. I guess it might even be larger than the stack size, right? So in general, if the size of the array is small, or we know that the size is small, let's say 1000, 2000 elements, a stack is fine. But it's always better to try to allocate on the heap. And again, C++ syntax is very similar to Java. How do we allocate memories on the heap, which is the only option that we have in Java? We use the new keyword. So here I can use the new keyword, exactly the same thing. JCC array is new, JDouble array num. So this is an extremely similar syntax to Java. Okay, let me just fix this typo. Okay, the problem here is that allocation on the heap. So heap allocation always returns a memory address. It returns memory address. It just tells us, okay, I allocated this, and here's the memory address of the first element of this array. So that means that we cannot have a JDouble here, right? It should be, basically, if I compile this, I probably get an error. I do here. And cannot initialize a variable of type JDouble, aka double, because we're using a type def, with a R value of type JDouble pointer, which means when we allocate on the heap, we always return a pointer. So this is a pointer, this is a memory address, right? So the type is in fact a memory address. But then we also said that for the stack, this C array was a variable that held the address of the array, right? The first element. So this is exactly the same. So all the other code that we wrote is the same. The problem here is that when we use the new keyword to allocate on the heap, we have to also basically remove it or clean up the memory or deallocate it. And the way we deallocate it with a delete operator, delete array operator, carray. All right. So we have to do this. Otherwise, each time I call this method in Java, I have adding more and more memory to the heap, but I never free them. So if I use a memory monitor tool like the activity monitor in C++ or task manager in Windows or whatever, and let's say you start to call this linspace method 10 times and then 100 times and then 1000 times, you see that the amount of memory that this program consumes is getting larger and larger, despite the fact that we're just calling the same method, right? And that's because we never deallocate or free the memory. So whenever we allocate something on the heap, we have to also free it or use a delete operator. All right. And again, in Java, we don't have this concept of freeing a memory because garbage collector does it in the background. But the good news is that being able to manually delete this memory allocation and free up the memory allows us to not have the overhead of garbage collector. Now, obviously, for a large project, this gets very complicated, manual allocation and deallocation. So it's always a good thing to have the garbage collector that we have in Java. But for a small function like this, when we're working with JNI, having this manual deallocation helps us to have a much better memory management, because the thing with garbage collector is we don't know when it actually runs, right? But here we know that we immediately deallocate it, free up the memory, so we always have a very nice small amount of memory. Okay, now what I'm going to do, so if I now compile this, it works fine. And then let's copy the dynamic library for binary here to our Java project and overwrite the previous one. And if I go back here, if I, let's say, create an array of size 5 million, right? So this translates into an array size of 5 megabyte here. And if I didn't allocate it on the stack, I may run out of memory because I end up with a stack overflow and then the JVM crashes. But here, this should just work fine. Yes, so let me just wrap it up here in the console, and we have no problem handling like 5 million elements on the heap, because heap is a relatively large size. Okay, and then so let me just terminate this one. Okay, and then the other thing here is that so it's always best to try to basically check the size of the array that we want to create, and then decide whether we want to put it on the stack or on the heap. Just keep this in mind, that the stack is a very small size, so you may run out of memory and then JVM might crashes. So be very careful about that. So this was all the discussion about primitive types, how we can deal with primitive types. But then let's go to another topic where we want to deal with arrays of objects. And the very simple example is a two-dimensional array in Java. Now, two-dimensional array in Java is completely a different thing than a two-dimensional array in C++. It's completely different. If you assume that the one-dimensional array is relatively similar, two-dimensional array is completely different. And again, a two-dimensional array in Java is still an object, right? So we're still dealing with an object. But basically, this two-dimensional array, we know that the double array is an object. So a double array becomes an array, basically a one-dimensional array of some object. What is each object? Each object is a one-dimensional array, right? It's an array of array. So arrays of objects are mapped to J object array. So for primitives, we had, for example, J double array, which was a subtype of J array. All of these primitive arrays are subtypes of J array, and J array is also subtype of J object. But here if I have an array of just an object itself, then we end up with a J object array, right? So a two-dimensional array excuse me, a two-dimensional array is an array of one-dimensional arrays, and each one-dimensional array in Java is an object, so we end up with a J object array, an array of objects. And then again we use our JNI environment object to create these arrays and fill them up with values from Java. So step 1, create a new J object array. Let's say J2D array. I want to create a J2D array, a 2D array, Java two-dimensional array. J object array, J2D array, environment, new object array. Now instead of having a primitive type like new double array or new int array, we use new object array. And again, we have to specify the length, right? And here basically we know that an object array, the length is the number of rows, right? Each row is an object. So when we're dealing with a 2D object, the number of objects in this object array is the number of rows, right? Number of rows in this double array. We pass in the length of the array. The same thing in Java, if I have a 2D array and say x.length, it tells me the number of the length of a 2D array is the number of rows, right? Because double array is an object. So the length of this 2D array is the number of objects inside of 1D array, which is the number of rows. So we create our J object array and then create C++ array and fill it with values you have. So let's say again J double array, I'm putting it on the stack, and then now we use the again the function that we use to create or copy elements from a C array into a Java array. So we create a J double array because we know that the type of each row is a array of doubles, which is a J double array, right? So J double array, J arrays, environment, set double array region. And then I'm assuming that I have already created a J double array somewhere, and then I'm just basically I'm just let me just because this environment set double array region, it doesn't return anything, so we have to go here. Let's take this C array, and this len2 is the number of columns or the number of double elements in each row, right? Or the length of each double array object that is inside. And then so we create a J double array, we copy these values, and then the elements of this J object array is J objects, right? So what we're going to do, we're going to cast this J array to J object. We just cast it and then set the element of the object array. So environment set object array element. So here we cannot, so for primitive types we can set the region from one index and the number of elements. For objects we cannot set a region of objects because it's not just simple bytes in the memory, right? So we have to go element by element. Set object array element, J2D array, which is our J object array, index k, and then what is the element that is to being set is J array object, which was a casting from J double array to a J object. All right, so we have to go element by element. So obviously this is more complicated than dealing with primitives, but sometimes it's best to sometimes we have to deal with these 2D arrays or an array of object. In general, if I want to deal with a 2D array, from the C++ I return a one-dimensional array, and then which has all the elements here, all the elements from rows and columns, and I just convert them to a 2D array in Java. That's always much easier and more efficient, but we can try both of them. So let's head to Eclipse here. I'm going to create a class test object array, okay, and here let's create a method called public double array, public native, it should be native double array, and then let's say func1, and then int rows int columns. So we just tell it, okay, let's call it, I don't know, ones. This takes a number of rows and columns and returns a two-dimensional array, which is a matrix that contains all the elements are 1. So a matrix of dimensions, rows and columns, which is all the elements are 1. So basically aij, the element ij is always 1, right? And then in order to do this, so we select this object and run our Java Edge tool to create the header file here, and it puts it directly in this header folder in our C++. So test object array here, and then I'm going to create a new compilation unit. So let's call it object arrays.cpp, and then the first thing is to include the header file, pound include, and then it's a relative path to the header folder test5, and then object array. Next we copy and paste this here, and then add the implementation. JObject is test object array, and JInt is rows, and JInt columns. Okay, so what do I need to do? I need to, step 1, create the object array. So JObject array, object array, obj array is environment, arrow operator, new object array, and then basically, let me go back to the PowerPoint here. New object array of length, but we need to also have 2 other things here. So let's see what these are. So if I create a new object array, the number of elements are the number of rows in our 2D, right? But we have to provide a J class and a J object init. So let's set init to null. Doesn't matter. And then, but we have to provide this J class, and this class is basically this J class, object class, is basically what type of object is going to be into this to be inside this array, right? An object array includes objects, right? Each element of this array is an object. So Java or JVM needs to know what type of objects we're going to put in, right? So I'm going to say environment find class, and we have to pass the signature of the object, and we already know the signature of the object, right? It's starts with L, and then the fully qualified name with some slashes and semicolon. Except for primitive objects, for example, for an array, the signature of a double array is a square bracket D, right? So what I'm saying here is that, hey, JVM, the type of objects that I'm going to put inside this object array is basically this basically it's just double arrays, primitive tuple arrays, right? So this still is complaining because the third element is so the third element here is a JObject pointer. And then let me just open this up. So init. So this initialization doesn't matter that much. We might be able to pass something like we should be able to pass null, but this is still complaining. All right, let's just pass 0, for example. It doesn't really matter. And I believe null is also 0, right? Could not be resolved. Null. We do have null in C++ as far as I remember, but we can just pass 0, so this doesn't matter. This is a initialization pointer, right? J object. So and then okay, so we create the object array, and then step 2 is to create each row, create each object element, which is a double array, create each element, right? So I'm going to say for int k equals 0, k less than columns, because each element of this object array is a double array that has the number of columns, right? And k plus plus. Actually, this should be rows because we are iterating over the elements. And here I create a j double array, j array, new basically environment, get a new double array of length columns. Now the length of each row is the number of columns of the 2D array, which is columns. And then basically what I'm going to say here is also create a C++ array, j double C array, and then of size columns, and then for int I equals 0, I less than columns, I plus plus, I'm going to set the C array I to 1, okay? And then I'm going to copy this C++ array to the J array. So set double array region, J array, index, length is columns, and then C array. And finally, I'm going to create a J object. J object, array object is, I take this J array and cast it to a J object. J object. Actually, we don't really need to do that because J array is already a object, so we most likely don't need to do this because of the polymorphism. But now I have this J array, which is the kth element of this object array, right? So environment set array element, set object array element. So we have our object array, and then at index k, and the value is J array. And eventually we're going to return this object array because we have to return a J object array. All right. So let's say return object array. So if I compile this, hopefully this compiles fine. Yes. And then we can copy and paste to our Java project and test it. And again, I am creating, so this C array is created on the stack here in the C++. Obviously, all the Java array creations, object or this double happen on the Java heap. So we don't need to worry about the amount of memory. But for C++, this is allocated or created on the stack. So we have to be careful. If we know that this the size is going to be very large, then let's say more than 10,000 or something, we have to allocate this C array on the heap, not the stack of the C++. But if I go back to my Java code and create a main method, and then just instantiate this, test new, and then let's call the method to create an array. Double result is test.ones 5 times 5 times 4, let's say. Okay, and then I want to sys out this, and obviously if I sys out the result, then I get just the signature and hash code. So we have arrays, and if I use toString, it again goes through each element and prints out the toString method on each element, which is an object, so it doesn't give me the actual values. But arrays has another method called deep toString, and then this iterates through each object, and if it's a type of array, then it goes through the array again. All right, so we have to also load the memory, system.load library, and then native underscore C. All right, as you can see, we have one row of 4 columns, 1, 2, 3, 4. And then how many items we have? 1 item, 2 item, 3, 4, 5. Okay, so the first dimension is the number of rows, which is 5, which means this 2-dimensional array is an array of double arrays. So each object in this array is a double array. And we have 5 arrays, 1 array, 2, 3, 4, 5. And each double array or each element has 4 items, 1, 2, 3, 4, and all of them are supposed to be 1. Okay, so this is how we deal with object arrays or 2-dimensional primitive arrays, or even if it was 3-dimensional, the same thing. A 3-dimensional array is basically an array of 2-dimensional arrays, right? And each 2-dimensional array is an array of objects, 1-dimensional arrays which are objects. So it's array of objects. But again, we have to specify this J class to tell JVM what kind of objects we are going to put inside this object array, right? And we use this method called find class. Find class is basically telling and the signature of the class. That's another reason to really get familiar with the signature of the classes and how JNI defines the signatures. Okay, and then the initial object doesn't matter. And then although we could add some, we could say, okay, initial, basically we know that the Java, when we create an array, Java initializes the elements of the array. So if I have 1-dimensional array of type object of type double, if I write something like this, double some array, I know that all the elements of the array are initialized to the default value of double, which is 0. If I have a Boolean array, all the elements are initialized to false, right? Array I is false. That's why this function new object array also asks us if we want to initialize it with something. And right now we're saying that no, we don't care about what you initialize it because we want to fill it up. This is another difference with C++ arrays. When you specify something, create a C++ array, it by default, this statement doesn't initialize C array. So if you look at the values of the C array at each element, it's some garbage value because it's some whatever is in that memory location at that specific time that we create this array. Okay, so to recap, we need to tell Java JVM or JNI what type of object we're going to put in this object. And for a 2-dimensional array, and again the signature is a square bracket D. Each square bracket means 1 dimension, and if this was overloaded, we end up with _3_3D, so we can test it. So let's say Boolean flag. Now we have overloaded this function, so the JNI has to add the signature of the parameters here. Okay, but okay, maybe we have to add the signature of the 2-dimensional parameter. So double array args. So let's select this Java object array and then run Java Edge. And this updates it now with the __ to signify the overloading. And then JNI has to add the basically method parameter signature. Here it's int ii, here is int and a double array, square bracket D. And each square bracket gets replaced by _3. Okay, so here we expect to see Java _ package name, test5 _ class name, test object array, underscore method name ones underscore which is overload, and the parameter signature int a slash square bracket d, and each square bracket gets replaced by underscore 3. Okay, so we expect to see this, and if I go to the header file and copy and paste this, it's basically the same. All right, now this was the case when we returned an object array, but let's say all right, so I'm going to comment this out to get rid of overload. Let's say we want to pass in an object array, a two-dimensional object array, and return some number. So let's say I don't know, a double, or basically a double array, or a double which says the max, and we want to pass in a double array, a two-dimensional double array x. So what we do here, we pass in a 2D array, and this function is supposed to return the maximum value in this two-dimensional array, maximum element. So if I select this Java file and then run the Java Edge tool, it updates the header file, okay, and adds this new method. So if I go back to the C++ and add the implementation, we have the environment, JVM, and then the object, and then JObject array is X. So again, a two-dimensional double array, a primitive two-dimensional type, becomes a JObject array. That's the only way, because this two-dimensional is basically an array of objects, and each object is a double array, and double array is an object in Java. So what do? We need to start with a let's say double, let's call it max val, and let's call it 1e I don't know, 20, a very large number, or maybe we can call it from 0 because we want to find the maximum. And then we are going to iterate through all the elements of this array and then compare them with max. If they are greater than max, we put them into max. All right, so basically what we need to do, int rows, we are going to, or j int rows, and maybe j double max. So let's use the JNI types. So environment get array length, and then x. So this tells me how many number of objects are inside this JObject array, which is the rows of the two-dimensional array. And then for int I equals 0, I less than rows, I plus plus, what I'm going to do, I'm going to get the ith element. So environment get object array element, get object array element, just like the one that we used previously. We used set object array element to set the element. Here we're using get object array element, which is x, and add index I, and this returns a j object, and we know that it's already, basically we know that this is a j double array. J double array, basically j array this. All right, and I guess I'm not sure if it will complain or not, but eventually what we need to do, return the max val. All right, so JObject, we probably want to cast it to j double array because this returns a JObject j double array. And now we get the j array, which is each row, and then we're going to get j int columns, and then environment get array length j array, and then iterate through it for int k equals 0, k less than columns, k plus plus. We want to basically say that if actually we cannot iterate through this double array. Now we have to create a J double C array. We have to create a C++ array of length columns, and then copy the elements over from this Java array to the C array. Basically get double array region, J array 0 columns, and the C array. And now iterate through this C array. So if max val is less than basically columns k or C array k, then we are going to say max val equals C array k. So we are comparing. If it's the max value that we initially start with is less than the element, we replace it with the element. Okay, and again I'm assigning this C array on the stack, just something to keep in mind, allocating on the stack, which means that I'm assuming this two-dimensional array, each row doesn't have many items, right? So this code should work, I believe. So it compiles fine, and then copy and then paste and replace the previous library, and then we go and test it. All right, so let's create a two-dimensional array. Double array is, we have 1.1 and 5 for the first row, and -2, -5.2 and 3.1 for the second row. And note that a two-dimensional array in general doesn't necessarily have rows of the same length, because each row is an object. So, and these objects can have different lengths, right? And then we want to get the result. Max is test.max array, and sysout max. So we expect to see 5 as the result. 5, yes. If I set this to -5, we end up with 3.1 as the result. Yes. So this code works. And again, as you can see, working with two-dimensional arrays is not easy, because we have to do this type of conversions, because when we have a two-dimensional array, it gets passed as a J object array or an object array, and then we have to basically get each element and then convert it to the J array, and then get the length of, because we cannot directly access each element of a double array, J double array. We have to copy all the elements into a C array and then process those elements through the C array. All right, but this works. My recommendation is always to basically try to unwrap this into a one-dimensional array, and always pass one-dimensional arrays. So if I were to actually write this max function, I would basically have a native method like this, which takes an array, and then I would basically typically add 0 here and make it private, right? And then in the public native public double, I make it a double, and then max double x. So what I do here, I create a double one-dimensional array y, which is new double x dot rows, x dot length, which is the number of rows. Maybe we should write it here, int rows, x dot length, int columns is let's say x0 dot x0 dot length. But the problem here is that we are assuming that all the elements have the same length, which might not be the case. So this is something to have in mind. But let's assume that all the rows have the same number of columns, and then I basically here create rows times columns. Typically when we're dealing with two-dimensional matrices, it's always correct that all the rows have the same number of columns, but in general that's not necessary here. And then I call the max0, the native method, on this unwrapped one dimensional. So for int I equals 0, I less than rows I plus plus. For int j equals 0, j less than calls j plus plus, y ij, or basically y some index equals xi and j. So how do we do this conversion? I times rows plus j. I guess this just works fine. When I is 0, we are in the first row, and then we iterate through the columns. And then when I is 1, we go to the second row, right? So we are unwrapping this two-dimensional array into a one-dimensional array, which has the size is different. And then I'm calling the native method on this one-dimensional array. Okay? So I always try to do something like this, because then it's much easier to deal with the one-dimensional array. So if I run the Java H test object array, we have this max 0 now. I can go to CPP and try to implement this test object array. And now we have a JDouble array, which is very easy to deal with. We just create a instead of having this long code to deal with object arrays, we just say jint len is environment get array length, and then pass in x, and then JDouble C array of length, and then environment. We just copy all the elements over. So environment get double array region, get double array region, x from 0, length, and then C array, and then we do our max here, right? So we do our basically for loop here. We iterate through the length here, and then okay, we can have also a JDouble max val is 0, and then return max val. So I always prefer to do something like this, because it's much easier to just copy the array over to a C++ array and then do the processing there. So if I run this, this works fine. But then the downside here was that when I converted this two-dimensional array into one-dimensional array, I assume that the number of columns is the same, but it may not be true. So if I run this right now, I get 1.1, but basically that's because, so if the first element, because I'm using the length of the first element, so let's say this is 5, and then so if the first element is so if this is, let's say, 13.1, I'm not getting that, because we assume that the columns, the length is 2, so we are looking only in these two. So the way I can fix this, I can basically say that we have to work a little bit on this function to make sure that even if the rows have different lengths, we can still find it. Now, obviously, if I set all the lengths to 2, I get the 13.1, which works fine. If I set this to 15, I should get 15, which works fine. But then the other thing is that this function max0, which is a native, and I made it private, which is always a good thing to do, finds the maximum of an array, right? So what I can do is basically do this. double max 0, and then for int I equals 0, I less than x dot length I plus plus, instead of basically and then I return max. So instead of trying to unwrap the 2D array and send it to the C++, I can just find the maximum of each row and then eventually look at all those maximums and find the maximum of all the maximums. So if max is less than max 0 of the ith row, then max is actually we can just calculate in max 1 is max 0 xi. We can call it max row, and then we find the maximum of each row, and if the current maximum is less than that, we just assign it. Okay, now this takes care of the problem of having rows with different lengths, because we are getting the maximum of each row separately. So even if now I have 15, 75, this should work fine. Yes. Now in the previous case, let me just comment this and uncomment the previous case. Here, because we're using the length of the first row, if the one is, let's say, 3 elements and the second one is 2 elements, we definitely or most likely run into array index out of bound some sort of exception, right? Because it assumes that the length of all the rows is 3, but the second one is 2. So this was definitely not a good implementation. Instead, what we did, we said that, okay, I pass each row to the C++ native method and find its maximum, and then of all the maximums, eventually I get the maximum value, which is 15 here. Okay, so I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.